This is part 6 in a series of videos in which I'm showing how I'm going about developing a 64k SRAM card for the Altair 8800. In the first 5 videos I got as far as getting a breadboard version of the memory card up and running, albeit with only the lower 2 data bits connected and the lower 3 address lines connected, but it from that point doesn't really make any difference if I connect up the rest. This is just a proof of concept, and the rest of the design will be done in the PCB CAD system. Through the previous videos I've mentioned that there were various features that I wanted to include in the card, and that there were specific reasons why I chose the particular memory chips that I did, and several questions that, could I select a different device? And the answer is yes, of course I could have selected one of thousands of devices. There are many different types of SRAMs available. But I just wanted to make this video before we go on to doing the PCB layout, just to further explain why I made the selection that I did. And before I explain it any further, I just want to demonstrate what one of the main features was that I wanted for this card. So I'll power up the Altair, reset it, and now I'll deposit an alternating bit pattern in the lower 2 data bits of the SRAM. This is the same test pattern that I used in the previous video. Okay, so if we now examine that data to make sure it's what we actually saved, we can see that it is indeed what we expected to see. So I'll now turn off the Altair, switch it back on, we'll reset it. Notice now that if we examine the data, it still contains the data that we entered. If I enter the alternate pattern that we used in the previous video, and examine that, we'll see that the bit pattern is again what we expect. And again I will turn off the Altair, turn it back on, do a reset, and we'll examine the data again, and you can see that the data that we entered is still there. What I've done here, of course, is add a battery-backed function to the SRAM. So the idea here is that if you're using it for normal operation or doing some testing, what you can do, for example, is enter BASIC into the Altair. If you then power off the Altair and then power it back on, BASIC will still be there until you decide to change it. So it's kind of like a ROM card. The advantage being, of course, that you don't need to open the machine, take the ROMs out and put in new ROMs. You can just change the memory contents either through your serial interface or even through the front panel, and then that data will be retained until you change it. So we'll have a quick look at the circuit inside just to see what the additions are that I've made to allow this to happen, and then I'll go into more detail as to why I chose the particular memory chips to actually do this. Okay, so looking back at the breadboards, we have the same basic arrangement we had in the previous videos. The difference is I've added some control circuitry, and here I've just cobbled together a hookup for a coin cell. That's what's being used for battery backup, and I've also made some additional changes which I'll discuss in a future video, but essentially in the videos I've shown up until this point, the card was working, but there were several fundamental issues that I'm sure anyone that's been watching this that is familiar with designing these cards will have been wondering about, and that was the design of the logic circuit that controls the card had a serious omission, and I'd left it out simply to simplify the explanation and the basic testing of the card, and that is that the memory contents would have been corrupted under certain conditions based on what other cards were fitted. And as I say, I'll explain that in more detail in a future video, but that has now been resolved by adding the additional control circuits. that was always the intention, but it does complicate the logic and trying to explain how it works, so I left it out in the initial explanations, but that is now in this setup. So back to why I selected this particular device. In the first video I showed you the white paper design for this card, and essentially the general, this is very much simplified in terms of a design white paper. I just didn't want to burden you with lots of boring text to work through. But each time I come up with a requirement for a design, then before I start putting anything together, I need to try to figure out what it is I'm going to be putting together so that I have a proper development plan. And so what I do is, when I have all the basic requirements sorted out, there are many others, but these are the most important ones, then for each of the requirements I need something specific to be looking at so I can research it properly. So in this case, what I wanted to do was look at each individual function that I wanted, and then do some research into each one to determine how best to go about achieving that. So this particular page is showing what particular requirements I wanted for the SRAM, and in particular I knew I wanted to make this board battery backed, but you don't want a huge battery. It's not really necessary if the board's properly designed. But one of the things that I needed for this was very low power in standby mode, and also I needed to have chip enable control for that function, along with the other parameters required for the memory chip. So I've been doing this for quite a long time, and I've used this particular SRAM chip many times. I've also used many other SRAM chips, and when you look at the specification for SRAMs, especially when you're talking about low power operation, then you do need to be very careful, because sometimes those specifications are only achievable under very specific circumstances, or the control circuits that are required to achieve that are very cumbersome. But I knew that these particular SRAMs were extremely good in terms of low power. I mean, probably an order of magnitude better than anything else I've ever used, which is why I picked this particular range of devices. That, along with the fact they're easily obtainable, very cheap, and you can get them in multiple footprints, which I'll show the footprints that I'm using on the card in the next video. It made this kind of a no-brainer as to use the particular SRAM chip, and I did. What I'll do, I'll reposition the camera. The Altair's still running. I'll reposition the camera so that you can see the current meter. I've got a meter monitoring the current being fed from the battery into the SRAM. So I'll just reposition the camera. Okay, so we're now looking at the Agilent 34461A. It's a 6.5 digit multimeter. It's currently set to the amp range. It's a very accurate meter, but importantly here it goes down to very low current resolution. Now at the moment it's showing zero current. The Altair is still switched on. This is connected between the battery and the circuit, so this is showing the true current coming out of the battery. The battery I've used is a 2450, but you could select any 3.6 volt coin cell that you wanted, and you'll see here that the current that the SRAM uses is going to be very low, and that was the target I wanted, and as I said, that's why I chose this particular SRAM. So the Altair is powered up. When the Altair is running, the power for the SRAM comes from the Altair, so the battery is not being drained at all. But I'll turn the Altair off, and the control circuit will switch over to battery backed. Now unfortunately the control circuitry does need to be a little bit complex, because you can't just use steering diodes in this application, because you do need to make sure that the SRAM remains deselected when the power goes off. But of course this selection, the chip enable lines, are fed from the control electronics on the card, so as soon as you turn the power off on the Altair, then they will drop to zero, and because they're active low, that would essentially enable the memory chips and draw a lot of power so you do need to include controls that will allow you to control the chip enable lines when the power goes off on the card. So I'll turn the Altair off and we'll see the current has now jumped up to just under 0.3 microamps. The battery is about 500 milliamp hours, so that will give us, in theory, just worked out purely in terms of the current that it's drawing, about 40 years of battery life. Now you won't get that for various reasons. Firstly, the battery self-discharges over a period of time, so you'll get probably half what you expect in terms of just basic calculation, which brings us down to 20 years backup time. Secondly, SRAMs have a tendency to draw more power as they warm up. It's about 24 degrees in here at the moment. If I put my finger on the SRAM, you can't see this on camera, but I'm putting my finger on the SRAM just to warm it up, you'll see that the current starts to climb. And the longer I hold my finger, therefore, up to a point, the higher the current will go. By the time the chip gets up to about 35-40 degrees, we'll be getting up around 3/4 of a microamp, which still isn't bad. That still gives us about 10 years, 15 years backup time. But the only time the Altair is ever going to get that warm is when it's running. But when it's running, the memory chip is drawing power from the Altair anyway, so it doesn't really drain the battery. It's only for short periods when the Altair has been running for a long time and got hot, and then you turn it off, that it's going to draw anything around half a microamp. Most of the time it's going to be down about 0.3 microamps. And this comes down to the second reason for using this particular device and using two memory chips. At the moment I only have one memory chip fitted, but when we put both of them in, we will of course be drawing twice as much current from the backup battery. So we'll be up to probably a peak of around a microamp. That's still quite good. That still will give us nearly 10 years of backup operation. But that's with this particular battery. If you want to put a smaller battery in, maybe a 2032 or something like that, then you might want to decide whether you want to fit both chips or just one chip based on the expected backup time. You do have other options. I don't know if you noticed it in the white paper. I did say I wanted some build options. One of those build options is which of the two devices, if any, you decide to battery back. You don't need to battery back any of them. I'll be showing on the PCB that there will be links where you can just omit the battery backup components and treat it as a standard SRAM card, so all contents will be lost in the event of a power off. But you can also determine which of the two memory chips to fit, and you can also determine which, if any, of the two memory chips you want to battery back, and you can do that individually. You can battery back just the first 32k, or just the upper 32k, or both, or neither. And that gives quite a lot of flexibility in terms of what features you want on the card, and also the expected lifetime of the battery backup. All things being equal, you should get a battery backup of around 10 years. I'll turn the Altair back on. You'll see that it automatically switches back to main power. And again, I'm still looking at the front panel. We still have the data entered that we put in as a test pattern. So that's the sort of thinking that I apply to the general design before I start assembling anything on breadboards. Certain ideas do change as I go along. This has been a very straightforward and simple design so far. I think I'm on the 5th day of the development for it, just putting in a couple of hours each evening. So you can see that the card is now quite well developed. It's going to have some very nice useful features for test purposes, or just for general use. You'll be able to use your Altair so it will boot straight into basic when you power it up without having to load it each time. Or if you want to modify what it's running, you can just change memory contents without having to open the machine, and then those contents will be retained until you decide to change them, unless you leave the machine sitting around for more than 10 years, at which point you'll have to re-enter the program. So that's it for this video. Any questions, then please drop a comment, and in the next video I will get on to creating the board layout.